Hello math learners, let's check this out. Which of the following sequences is not arithmetic? We have 5 different given which is all about sequences. Question is, which among these given are not arithmetic? Okay, the first one would be arithmetic. The second one, it will be not arithmetic. The third one would be an arithmetic sequence. The fourth one is not an arithmetic sequence. And the fifth one is not an arithmetic sequence. The next, we have here supply the unknown term. 4, 12, blank, 108, 324. In order for this to become a sequence, we need to consider the number 36. Okay. For the second example, we have 16, 32, blank, and 128. The number in the blank should be 64. Blank, 20, 40, 80. I think that should be 10. 27, 9, blank, 1, 130. I think it would be 3. And finally, we have 120, 60, 30, and the last one would be 15. Question: how did I get all of these answers? You want to find out? Stick around. I'll show you how. Hello math learners! Welcome to another session here in ML with Sir Ash. This is still your free access math teacher Ash. And today, we're going to discuss the most essential learning competency-based lesson for grade 10 mathematics, which is for quarter 1, week 3. And this is all about how to illustrate geometric sequence. Now, we have answered earlier 2 types of questions, which is to determine which among these sequences are not arithmetic and what is the unknown values in these given sequences. Now let's consider this first example. Remember in our lesson in arithmetic sequence that arithmetic sequence is the sequence in which if you consider 2 pairs for each pair in a given sequence, it follows a common difference, meaning the difference between each 2 sequence or each 2 terms are constant. Now let's consider the first example. This is an arithmetic sequence because 20, 13, 6, negative 1, negative 8. If you consider the difference of 20 and 13, that is 7. 13 and 6, that is still 7. 6 and negative 1, that is still. Now since the given sequence is decreasing, meaning going down, therefore the difference is negative 7. Now, since the given difference is constant, they are all common, then we can say that this is an arithmetic sequence. Now, going to the second example, we have 1, 3, 9, 27, and 81. 1 going to 3, that is 2, right? 3 going to 9, that is 6. Now, you don't need to finish all the difference on the next 2 terms because the first 2 terms doesn't give you already a common difference. Therefore, you can now say that this given sequence is not an arithmetic sequence. Okay, now going here, negative 5 to 0, the difference is 5. 0 to 5, the difference is 5. 5 to 10, the difference is 5. 10 to 15, the difference is 5. Since this is increasing, meaning going bigger, therefore, we have a positive common difference. And we can consider that this is arithmetic. Easy, right? Okay. Now, going to our fourth sequence, we have 1, negative 1, 1, negative 1, 1. The difference between 1 and negative 1 is 2. The difference between this one is still 2. This one is 2. This one is 2. However, if we consider the direction of our sequence, going here, this is decreasing. Therefore, that is negative 2. From here, going here, that is increasing. That is positive 2. From here, going to this part, negative 1, it is decreasing, so negative 2. Therefore, even though you have the same value, which is 2, positive 2 and negative 2 are two different numbers, right? Because one is positive, the other one is negative. Therefore, we don't have a common difference. We can say that this fourth sequence is not arithmetic. Okay, and finally, we have here negative 4 going to positive 8, that is 12. 8 going to 16, that is 24. 16 going to 32, that is 16. Now, as you can see, first to the second example, or first term to the second term, it gets bigger, so therefore, it is positive 12. 8 going to negative 16, it's going smaller, or it is decreasing, therefore, this is negative 24. Having these two differences, which are not the same, then we can already say that this example, this sequence, is not arithmetic. That's easy, right? Now, the question is, Sir Ash, this is not arithmetic. So, what is this kind of sequence? Okay, that is what we call geometric sequence. Okay, so therefore, we can just say that these non-arithmetic sequences are what we call geometric sequence. Okay, or GS. The spelling is GEOMEERIC and then sequence. Now, don't get me wrong, my dear math learners. There are a lot of different types of sequences. The first one is arithmetic, the second one is geometric, and there are others. Meaning, if it is not arithmetic, you cannot say that you have already a geometric sequence. There are also certain rules that we need to consider in order for a sequence to be geometric. Later on in this discussion, you will know what are those rules. Okay, now let's go here. How do we get the missing terms of these unknown terms or this sequence? We have 4, 12, 36, 108, 324. I have answered 36. Why? Because as you go here, the difference of 4 to 12, that is 8. Right? Okay. The difference of 108 to 324, 8. That's big. Okay. So that is 108 minus. So we have here 14. That is 6. 1. That's 216. Right? Okay. So the difference of these two is 8. The difference of these two is 216. We can already say that this is not arithmetic. But you can consider other operations. You can ask yourself, what happens to 4? Why it became 12? It was multiplied by 3. So therefore, this is multiplied by 3. We can consider that logic. The second one is this pair. What happens to 108? Why it became 324? Now, if you consider 108 times 3, that is 3 times 8, 24. 3 times 1, that is 3, and that is 324. Therefore, this one is multiplied by 3. Therefore, I can say that these two pairs follow the same pattern. So, in order for me to get to the unknown term, I need to consider 12 multiplied by 3. And that number, if ever I get that number, I will multiply it again by 3 and I should arrive to 108. Now, let's try. 12 times 3 is 36. Very good. 36 times 3, that is 108. So therefore, we have established that this sequence uses the pattern multiplication of 3 in order to be completed. Okay? Alright. Now, so that is the first example. The second example, 16, 32, blank, and then 128. The number that I use is 64. Why 64? 16 to 32, we have a difference of 16. Now, we cannot compare another term for 128, right? So now, let us refer to the first given. If we use 16, we add it to 32. 32 plus 16 is 48. if I use 48 here, that is 48, then I will use the common difference, which is 16. I should arrive to 120 in order for the sequence to be correct, right? But if I add 8 plus 6, that is 14. Carry 1. That will give me 64 and not 128. Therefore, what should I do? I will not consider the addition or the common difference between the first two terms. I will ask myself, what happened to 16? Why it became 32? So you can just answer, Sir Ash, it was multiplied by 2. Okay. So if I multiply this by 2, 16 times 2, that is 32. Now, if I follow that pattern, 32 times 2, that is 64. Okay? Now, if I continue the pattern, 64 times 2, that is 128. Therefore, the answer 64 must be the number in the unknown term. And that is how we get the next number. So now you have the idea, if it is not applicable for addition or the common difference, then we can consider the process of multiplication and division. Okay? Now, let's go here to the third example. The first one is blank. 20, 40, 80. Now, I must admit, math learners, you must first consider the common difference. If it is not applicable, then consider the multiplication or the division. Okay. 20 to 40. What's the difference? It is 20. Right? 40 to 80. What's the difference? That is 40. Then, there is no common difference. Now, we go to the next operation. Multiplication. What happens to 20? Why it became 40? So, it is multiplied by 2. Okay, so it is multiplied by 2. If I follow that one, 40 times 2, that is 80. Therefore, the pattern here is times 2. However, we are going back. So, 20, what is the opposite of times 2? That is divided by 2. So, 20 divided by 2, that is 10. Now, if I check my answer, 10 times 2, that's 20. 20 times 2, that's 40. 40 times 2, that is 80. Easy, right? Okay. Now, let us go to the fourth example. We have here 27, then it became 9, then unknown, then 1, then it became 1/3. We all know that this is decreasing. What happened to this one? Okay. The difference is 18. Okay. Now, for sure, we cannot see that the difference here is 18 because 1 minus 18 is negative 17, right? So, therefore, it is not 18 that we are considering here. Okay, so let us ask ourselves, what happened to 27? Why it became 9? Okay, the answer is, it was divided by 3. So, if we follow divided by 3, 27 divided by 3, that is 9. We follow the pattern. 9 divided by 3, that's 3. 3 divided by 3, that's 1. And 1 divided by 3, that is 1/3. So therefore, this pattern is now completed. Okay, now going to the final, we have 120, 60, 30, and our answer is 15. How did we get that? 120 going to 60, the difference is 60. While 60 going to 30, the difference is 30. Since this is going down, this is negative 60, negative 30. However, they are not the same. They are not common difference. So we need to consider other operation. What happened to 20? Why it became 60? Sir Ash, it was divided by 2. So, 120 divided by 2, that is 60. Okay. Now, let's apply that pattern. 60 divided by 2, that is 30. Correct. Now, let's just continue the pattern. 30 divided by 2, and that is 15. Therefore, this is our final answer. Now, you have the idea of what is geometric sequence mean. Okay. Now, let's just try to review your ideas about arithmetic sequence before going deeper to how to illustrate geometric sequence. Okay, math learners, we have here a very quick review about our previous topic, which is all about arithmetic sequence. Given that this is an arithmetic sequence, the first term is 2 and your difference is positive 3. Question is, what is the next 5 terms? Now, you don't need to use the formula in order for you to solve the first 5 term. Okay, the next 5 terms, sorry. We already have our first term, which is 2. Right? Now, knowing that we already have our difference, which is positive 3, then what we'll do is we just add positive 3 to the first given and we continue it 5 times as much. Okay, so 2 plus 3, that is 5. 5 plus 3, that is 8. 8 plus 3, that is 11. And 11 plus 3, that is 14. And 14 plus 3 is 17. So, question is, what is the next 5 terms? 5, 8, 11, 14, and 17. You got it, right? Okay, because we already have discussed this kind of scenario. Now, let's consider this example. We have 4, 8, 16, 32, 64, and the next 3 terms is unknown. Question, how will you get the next 3 terms of this given sequence? The first thing you should need to consider is the given sequence arithmetic? If yes, then you just need to use the pattern, which is adding or subtracting a certain number in order to obtain the unknown terms. Now, let's start considering the difference of the terms. The difference of 4 and 8 is 4. The difference of 8 and 16 is 8. It's not common already. Therefore, this is not an arithmetic sequence. Now, we will not use the addition or subtraction in this matter because it will not give us a common difference. Now, the next is to consider the next operation, which is multiplication. What happens to 4? Why it became 8? What needs to be multiplied? Okay, so that is 2. You multiply it by 2. If we apply the same pattern, 8 times 2, that is 16. 16 times 2, 32. And 32 times 2 is 64. As we can see here, this is the same, right? Okay, this is the same. So we can just apply our pattern by multiplying 2. So 64 times 2 is 128. 128 times 2 is 256. And 256 times 2 is 512. Therefore, you have completed this given sequence. Question is, Sir Ash, if in arithmetic sequence we use the common difference, how about in the geometric sequence? In the geometric sequence, if you establish the common factor to use, whether it will be multiplied or divided, in order to get the pattern, that this 2 here is what we call the common ratio. So, to differentiate, for arithmetic sequences, we use common difference. For geometric sequences, we use common ratio. Okay? Again, for geometric, we use common ratio. For arithmetic, we use differences. So therefore, since this is common ratio, we will not use the letter D. Instead, we will use the letter R. Okay? So this is still the first term, the second term, and so on and so forth. Okay? Now, let us consider some more examples. Okay, math learners, we are here to our final examples for our discussion for today. We have here solved the next 3 terms of this given geometric sequence. And we have also here solved the common ratio. Okay, let's start first in this given scenario. Your first term, a sub 1, is already given. And your common ratio is given. Now, remember, when the common ratio is given, You just need to use multiplication or division in order to get the next term. So you might ask me, Sir Ash, when do we use multiply or divide in getting the next terms? Now, it is very simple. Just consider that if it is whole number, commonly we are just using multiplication. But if it is a fraction, then there is still multiplication, but on the later part, we need to divide. Okay. The first term is 2 and the common ratio is 4. So we start with 2. Okay? The next given is the ratio is 4. Meaning, you will use 4 as a multiplier to your given. So 2 times 4, that is 8. 8 times 4 is 32. 32 times 4 is 128. Okay. Next 3 terms. Only 3 terms are asked. So therefore, we have already established our answer. You can now check. 2 times 4. Is it correct? Yes. 8 times 4, 32. Is it correct? Yes. And finally, 32 times 4. 4 times 2, that is 8. 4 times 3, that is 12. 128. Okay? Very easy. Now, let's go to the second example. We have negative 4 and our ratio is 2. So, we multiply 2 here. So, negative 4 times 2, that is negative 8. Negative 8 times 2, that is negative 16. Negative 16 times 2, that is negative 32. So, I already have the answers. Now, let me emphasize this. Remember, in arithmetic sequence, if the sequence gets bigger, your common difference is positive. When the given sequence is getting smaller or decreasing, your difference is negative. Now, let's consider our first 2 examples here. Both sequences has a positive ratio, right? They have a positive ratio. Therefore, for a common confusion of the students, they will consider that, oh, I think the sequence will be increasing. 2, 8, 32, 128, that's increasing. However, negative 4, negative 8, negative 16, and negative 32, that is decreasing. So, now math learners, remember this. Whether your ratio, your common ratio is positive or negative, you cannot say that your sequence will get bigger or decreasing. It will always comes down to the given ratio when you multiply them. Okay? Remember that when a negative is multiplied by a positive, it will still be a negative. A negative, a negative, a negative. As long as they are unlike signs. Okay? Now, let us continue. We have here positive 3. Positive 3 and our common ratio is 3. So, 3 times 3, that is 9. 9 times 3, that is 27. 27 times 3, that is 81. So you have the next 3 terms. Easy, right? Okay. Next is we have 320. Okay. Now this is the tricky part. We have here 1/2. Sir Ash, we have here 1/2. How do we use 1/2 as our multiplier for 320? Now remember, in multiplying a whole number to a fraction, that whole number will be first multiplied to the numerator, then will be divided by the denominator. So 320 times 1, 320, divided by 2, that is 160. Next, 160 times 1, that is still 160, divided by 2, that is 80. 80 times 1, that is 80, divided by 2, that is 40. Therefore, if you multiply 320 by 1/2, you will get 160. 160 multiplied by 1/2, you will get 80. 80 multiplied by 1/2, you will get 40. And that is how you get the next 3 terms if you have a geometric sequence and you have a given for the first term and the common ratio. Now, the next question is, Sir Ash, what if the sequence is given and the common ratio is the problem? Okay, we have that in our second group of problem. Now, we have solve the common ratio given this given sequences. Okay, 2, 4, 6, 2, 6, 18, 54, 162. Now, it is very clear that there are no common difference on this one. And it has been established by the instruction that we are getting common ratio. So, you don't need to subtract or to add anything. You just need to ask yourself, what happened? Was it multiplied or divided? Okay. We have 2 going to 6. What happened to 2 to become 6? What must be multiplied? Okay, that is times 3. Next, 6 going to 18. What must be multiplied? Okay, that is still 3. 18 going to 54. What must be multiplied? That is another 3. And same goes we have here. Therefore, our ratio is positive 3. Now, if you are confused on that technique, you can do it on a backward position. 162 divided by 54, answer. 54 divided by 18, answer. 18 divided by 6, answer. 6 divided by 2, answer. And that is 3. Okay. Next, let's just apply that one from the backward position so that we can have a complete answer. Okay. 135 to 45. So Ash, it's so big. Okay, let's consider this one. 15 to 5. What is 15 divided by 5? So Ash, that's 3. Okay, 3. 45 to 15. 45 divided by 15. Okay, that is still 3. 45 to 35, 135 to 45. Now we can say that is still 3. So therefore, our answer for this given, I already have written the answer. Okay, so the answer for our second R is 3. Okay, very good. Now let's go to this part. Now this is the tricky part, right? Okay. We have 1 half, 3 halves, 9 halves, and 27 halves. How do we get the common ratio? Okay. Now, you can use this one. 27 over 2 divided by 9 over 2. 9 over 2, okay? You can use that one. So, let's just write here. 27 over 2 divided by 9 over 2. Now, remember the rule in dividing fractions? We use the reciprocal of the divisor and then proceed to multiplication. How do we do that? We copy our dividend. We get the reciprocal. That's 2 over 9. Okay? And then the divide will become multiplied. Now you can use cancellation if you can see anything on this one. So we have 2 and 2. You can cancel them. Okay? That's 1. And 27 and 9, you can also cancel it. This will become 1, this will become 3. Because 27 and 9 are both divisible by 9. Okay. So 3 times 1, that is 3. 1 times 1, that is 1. So 3 over 1 is 3. Therefore, the ratio here is 3. How about this one? Okay, same scenario. We have 9 over 2 divided by 3 halves. That is 9 over 2 divided by 3 halves. So that will become 9 over 2 times 2 over 3. Cancel this one. 9 and 3. You can use the cancellation also. This will become 1. This will become 3. So that is still 3 over 1, which is 3. So therefore, this is 3. Same goes if you use this one, the answer is still 3. So therefore, our common ratio is 3. Sir Ash, it's always 3. Okay, can we consider that this is also 3? Oh, that is a big no-no, my dear math learners. Never assume in mathematics. Always try your best to solve every problem. Okay, now let us go to the final example. Now for the final example, we have here 1. It became 1/4. Then it became 1/16. Became 1 over 64. And then 1 over 256. How did we get that? Okay, so you can divide, okay, the second term to the first term. Okay. So Ash, how do we divide that? Remember, if you have a whole number, all whole numbers has an over 1. Okay? Then, that will be 1/4 times the reciprocal of 1 over 1 is still 1 over 1. Okay, so 1 times 1, that is 1. 1 times, 4 times 1 is 4. So your answer is 1/4. For the first pair. Okay, now let's consider the second pair. 1 over 16 divided by 1/4. So therefore, this will become 1 over 16 times 4 over 1. Cancel, cancel. This is also cancelled, but this will become 1, and this will become 4. So we have here 1 times 1, that is 1. 4 times 1, sorry, that is also 4. And they are just the same. So therefore, 1/4, 1/4. Now we can consider that they have the same ratio, and that is 1/4. Okay, so let us wrap up our discussion in illustrating geometric sequence. The first one is that geometric sequence is a set of numbers or sequence in which it uses a common ratio. This common ratio is done when you are getting the process of multiplication or division. But mostly that is multiplication, because if you use the division, then basically your ratio is a fraction. Okay? And then in getting the common ratio, you can just divide the second to the first. Remember, second to the first, not first to the second. Okay? Second to the first, third to the second, fourth to the third. Okay? So you start on the later part going to the term before it. Now, finally, in our getting the three terms or the next terms, we just need to consider the first term or one term, and then you just multiply it to your common ratio to get the preceding terms. Okay, and now this is the time that I will be challenging your intellect whether you have understood our lesson for today. And here it is. I hope you have learned a lot of things about the introduction on how to illustrate geometric sequence. This is still your free access math teacher Ash. And always remember, it's fun to learn mathematics if we are together learning. Thank you so much to all your support. For those people that I helped in this channel, I am very, very amazed and grateful to all of you students and even the parents there helping their child in this pandemic. Stay safe and God bless us all. Fellow math learners, if you think you like this video, hit the like button and the subscribe button. That is, if you are committed of learning mathematics the easy way. Thank you.